For each of these problems, we will have been given the graph of an exponential function. Sometimes we refer to those as a J curve, although it's a little bit of a misnomer because, you know, the letter J, when I draw in the letter J, kind of think about it curving back up, and these do not curve back up. And then a J, you know, this one obviously doesn't quite look like a J because it's upside down. Okay, but we've got our exponential curves. In every single exponential equation, aside from the fact that it sort of resembles a J, is that it follows along a horizontal asymptote. In this particular one, it's this purple line right here. So this purple line, so I've got this curve that's drawing really, really close to the purple line as I move to the left, and then it's going down. Now they go down so fast, or they go up so fast that it looks like there's a boundary line, but there is not. It's going down to the right, down to the right, down to the right, down to the right. It's going to forever go down to the right. So eventually this graph is going to be clear over at 100 or over at 1,000,000, but it's going to take a really, really long time for that to happen. Domain is about how far is your graph going to go to the left and how far is it going to go to the right. Well, this graph goes, the blue one that I'm following there, the blue one goes forever to the left, and it looks like it's not moving to the right very far, but it is. It's going down right, down right, down right. It's going to go right forever. So since it goes left forever and right forever, the domain is all real numbers. The range is about the height, the y's. So how high can it go and how low can it go? The highest this graph can ever get to, it's getting closer and closer to this line that's at -2. So it's never going to go above -2, but it's going to go down forever. So the y coordinates, range is about y's, the y's are never going to be bigger than -2. So what we're going to say is that our y stays less than -2. Notice it's not underlined because it's never going to reach a height of -2. It's just getting closer and closer and closer to this line at -2, but it's never going to touch it. Okay, so let's look at a couple of more examples. Okay, so this exponential curve right here, the domain, how far left, how far right. So this blue, it's going to go forever to the left. It's going up, up, but it's going left, left, up, up, left, left, up, left, left. So it's going forever left and it's going forever right. So the domain is all real numbers. And then the range is the height. And this one goes up forever, but it's never going to go lower than this purple asymptote that's at 2. So my y coordinates are going to be bigger than 2. So y is greater than 2 because it's going to have to stay above 2. Okay. 2 more here. So this curve, it goes forever to the left and it goes forever to the right. You're starting to see a pattern on the domains. All real, all real, all real. Every single exponential function, the domain will be all real numbers because every J curve will move forever to the left and forever to the right. But the range, this one is bounded. It has a ceiling at 3. So we can't go above 3, so our y is going to stay less than 3. Okay, so last one here. Hopefully if you're starting to see that pattern, every single one, the domain of these exponential functions, all reals. This one goes forever to the left and moves forever to the right. So all reals, then range how high to how low. This one is going to have to stay above -3. So my y's are greater than -3. So if something is staying above the line, its y is greater than. If something is staying below a line, then this would be y is less than.